Okay, and welcome to television class. This is our first content lecture here, and today we're going to talk about the signal flow. And signal flow is a very basic concept regarding television production, and it's a relatively simple thing to understand if you put it in context, and you're going to see that it's important in connecting other things together, literally. When we talk about signal flow, let's first start with what signal flow actually is, just to make sure we understand that much. Signal flow is the flow of information, and information basically transferring between one piece of equipment and another, and then ultimately to the home screen, whatever it is you're looking at it on. And so generally, signal flow starts with the camera. But oddly enough, not always. Okay, originally moving images were recorded on film. So let's go back that far. That would be like 100 years ago, where you had film cameras. And so let's say you're shooting a movie, and your camera person is there following the action. The camera person cannot see what the film is going to look like. Nobody else can see what the camera is even pointing at. Basically the spectators, they see a camera there, they don't know what it's producing, and the director doesn't have that ability either. The director is hoping that the camera operator is pointing the camera in the right place, and so they don't find out until they develop the film. And so then the director, watches the film projected in the theater, or watching the dailies, whatever you want to call it, and then they get to decide whether or not the shoot was a success. And of course, while they're showing the film in the theater, assuming there's only one copy of the film, nobody can see it but them. And so it's a very limited thing. Now, nobody would see anything until the film was processed. The film, when projected, would only be seen by people in the theater. Television was revolutionary because television takes that whole process and adds an electronic element to it. Now, electricity, as you might already understand, travels from one place to another, and it gets there very quickly. So, for example, when you flip on your light switch, it's not a really big deal how long it takes the light to come on. Usually it comes on basically instantly. And so that's how television works. The television signal, the video signal, works like electricity. And electricity can do a few different things. Now, if you ever notice people with plug strips, you plug one into the wall, you got like 6 outlets or something like that, you can do that with video as well. It used to be that was harder to do. Now it's gotten a lot easier, and now it's streaming and Bluetooth and all that other stuff. And so we'll talk about how we get to that point. Okay, with television, a video signal is sent from one place to another or many places at the same time, which we just basically said. It works the same way as the flow of electricity. Now, this is an example of what the early television signal looked like. And so what you're looking at there, believe it or not, is one complex signal. So if you look at the screen here, or if you follow my mouse, it literally starts here, does all this, and goes there. This is like a wave from one end of the wave to the other, and then it repeats. And so every time it repeats, it adds information. And so this represents 2 frames of video, and we'll talk about what that means with the next lecture. This little blob here, this spike, that's where all the color information is in the television. And if you see anything up here, that's the lighter areas of whatever image you're looking at. That's the darker areas. You got this really, really deep area here, what's called the sync tip. That's between video frames. And so essentially, this very, very complex signal is created by the camera and is sent out to wherever it is supposed to go. And so that was the television signal. And believe it or not, even though it isn't done the same way, even though it's digital now, the signal itself is basically the same. It's treated the same way. Okay, going back to signal flow, video cameras record images by scanning the film plane. And so basically, if you took a film camera and you remove the back of it, you would see what the film plane was. That's where the film is supposed to go. In a television camera or video camera, that's still there. They just put a piece of electronics there which measures whatever is hitting that. And so instead of having film record the image, you basically have it sent into an electronic scanning system, which will keep track of whatever that thing sees. And so that's basically how television has worked since its introduction really back in the 1940s. This creates a real-time signal that exits the camera via a cable. There's a cable coming out of the camera which takes that video signal. The signal can then be multiplied and routed to different places, which is an expensive used to be an expensive process, but it's very useful, meaning that you could have it so that whoever, when the camera operator is there shooting the image, there's more than one person that can see that. So the camera operator looks into the viewfinder, which they can actually see what the camera sees, and the director will be able to watch real time on a television screen, etc. And of course, this signal can be mixed with other signals. You can add text in front of it. You can blend more than one camera together. You can add something else that is not part of the camera image. And so all collectively, you can make your entire program that way. And of course, it can be recorded permanently. In fact, it should be. Finally, a completed video can be distributed in the same way. So essentially what you're doing here is you're making final videos and you're sending it out through television, however you're doing it. Okay, now what we have here, I wanted to show you this. This is an example of what's called a distribution amplifier, just to show you how complicated this can get. So if you look at this side of the screen, you'll notice it says input. You would take the image, let's say from a video camera, because that's a video camera input. It uses a BNC cable, which you'll know what a BNC cable is soon. Plug that in, you can get 7 outputs of the same signal. And this is a particularly complicated one. It apparently has a secondary input or something else like that. And so these things can get complicated and expensive. And of course, these days with Bluetooth, they're hardly used anymore. You'll see what I mean. Okay, electronic versus digital. And we all love the digital world. And many people don't understand that there is a difference between the electronic and the digital. A very big difference, as a matter of fact. And the funny thing is, nobody really can point their finger exactly when everything switched over. Meaning that there was a time when your television was analog. It was electronic, but it had nothing to do with the computer. The computer didn't speak the same language. And then sometime in the 90s, the computer got better and better at mimicking television. So you would have television producers using computer graphics in their video, and then eventually they would have to convert them from the computer graphic to video format on tape usually, and then you would see it that way. And then of course gradually we got to the point where they merged, and then eventually there was no analog anymore. So your television pretends to be analog, even though it is not. It's all digitally managed, and basically that's that. And so a lot of these old analog stuff, we still have vestiges of them, but not the same way. Okay, so the video signal started out as analog. We've said this before. The signal was arbitrary and could be distorted. That's important to understand, is that if you have an analog signal, it can, let's say you got a bad cable, you can have an intermittent connection, you may lose color information. Now, if you get a digital signal, usually, not always, but usually, anything goes wrong at all, it just stops working. Which can be worse, meaning that you might be able to fix a bad video signal, but a completely non-existent digital signal you may not be able to do anything with. But the video signal was arbitrary, and worse, it was not consistent. Meaning that if you play back the same videotape on 2 different decks, it can look different because they're interpreting the tape. And if you have 2 different cameras, it can be almost impossible to get them to look the same because they're creating different signals with different equipment. Okay, the equipment used to create the recording and record the signal was heavy and complicated. Now I can attest to this. Basically, you had a camera out in the field, and the video camera only generated the signal, meaning that that was where the signal came from. Your camera did not do anything else but create a video signal. And then, if all you brought with you was the camera, you wouldn't come back with anything. Basically, you'd just be producing the video signal, and it would just be sitting there doing nothing. Okay, the signal from the camera would have to be recorded on a large videotape machine. So you would have your camera out in the field, which weighed about 20 pounds. Then you would have a field deck of some kind, which the batteries alone weigh like 10 pounds. And so you have this heavy field deck. People would carry them over their shoulder, or you'd set it up on a table somewhere, and of course you'd have to bring tapes, and then you would record on the tapes. And then in order to see the recording, you would have to have some kind of a field monitor and other equipment. And so the average video shoot, even a single camera shoot, was cumbersome. And of course, editing was done by playing back and recording tapes. And tapes are the most unreliable things you will ever see. Meaning that if there was a slight defect in the tape, 20 minutes of your programming could be completely unusable, because the tapes were 20 minutes long. And so you'd be praying that didn't happen, because you wouldn't know until you played it back. And all kinds of other issues can happen with tape. For example, if you record right to the end of the tape, you may not be able to use the last few seconds of the footage, because it may cause the editing machine to balk at a certain point. So that's basically, those are problems you don't have anymore. And all of this was random and unreliable. And so there's many issues that were wrong with the electronic world of television. Now, on the other hand, digital technology is all computer-based. And so for that reason, and this is a real miracle, you can use the same computer you use for your schoolwork or anything else you like to do your video work. It doesn't matter. It's the same thing. It all speaks the same language. And so, for example, there's still a signal, but now it's comprised of ones and zeros. In fact, it's even using the same transmission and reception abilities. It's basically just a radio signal, but it's formatted in a very different way. And in most cases, this means smaller equipment. In the case of the camera, you basically lose the deck. Because I remember when the first camcorders came out, there would be a big video camera with a big deck on the back of it, and you'd balance it on your shoulder. And so, yeah, that would be portable, I suppose, but I wouldn't exactly call it comfortable. And so the modern video camera is obviously a good deal smaller, but it has its own recording capability. Oftentimes, it'll handle your audio for you, too, whereas back in the world of analog, you'd have to have a microphone going into the deck to record the audio that way. Okay. Cameras often record their own systems. Tape is gone, thank God. Believe me, you don't want to ever even dream of using videotape, and hopefully you never will. And the digital signal often contains both video and audio information, and even other things like closed captioning and things like that. And so all of that can be handled digitally. And all readings are exact and never change. And that's really one of the things that makes digital video so much better, is that essentially, if you've got, let's say, a color, let's say you have a background that uses Methodist University green, you can set that exactly. You don't have to try to approximate it and guess at it. And then when you record it and play it back a few times, it's still going to look exactly the same, because every time you record it to another let's say another project, then whatever is playing it back will be playing it back exactly. It's just transferring that information, and it's not being changed because it is an analog. It's digital. Okay, now signal flow itself, let's talk about that. Anytime the video goes from one unit to another, we have signal flow. So usually you'll have some kind of a cable coming out of the camera, going into something, even if it's just a field monitor, which can be useful. You can also put it into some other device, which transmits it in other places as well. In a live studio production, this can get pretty complicated, and I'll show you an example of that in a minute. Cables are used to send information. So basically, you have all kinds of different cables, and there are many of them, that go from one camera to another, that go from computer to computer. Some of these you know pretty well. You can have splitters and distribution amplifiers to route the signal, and you can convert the signal to other formats, which we do more of that than we really want to. It would be more convenient if we didn't have to do that, but sometimes, depending on the equipment you're using, you kind of have to. Okay, this is an example of a very simple signal flow. So if you look at this image here, you'll see that you've got a camera, and this looks like a very small camera, and it's producing an image, and so this would be what the photographer would see, and you've got what looks like an HDMI cable coming out to a field monitor. And so this would be, it could be that this is what you want to look at as a photographer. It could be the producer's standing over your shoulder and they want to see it too. And so this gives them a better view. So that would be about as much signal flow as you would run into in the digital world. This would be a much more elaborate signal flow. This would be, for example, for a multi-camera shoot. So if you look over here, you've got 4 cameras. Each of those 4 cameras are going into this unit, which we actually have one of these. This is called a TriCaster. And so the TriCaster takes that, and they've indicated here that they're recording a video output for some reason. Now, we wouldn't really do it this way. We would be recording it internally, but hypothetically, if you wanted to send out analog video, you could. And there, they have another output in HDMI going to a projector. So what you're seeing there is you're seeing the show. Those are the cameras. This is a mixer where they basically ready camera 1, take 1, and so it's going from these particular cameras. And so this is the output of the finished product. It can go out to a projector, it can go out to broadcast, and they've got a bunch of other possibilities there. And so that's just the basics of it. And so signal flow, it's important to understand how cables work. It used to be more important to understand the order. It used to be that signal flow was complicated enough that you could get the order wrong. Let me give you a quick example. Let's say you got a camera and all it's doing is putting out a video signal. It's not doing anything else. And let's say you got a video recorder and you got a monitor. It is possible to run the signal from the camera to the monitor and then from the monitor to the deck. Why do you think that might be a bad idea? Well, the answer is because if there's a break in one of those cables, you would never know. If it's not getting recorded, if the video is going to the recorder first and then to the deck, so the recorder first and then to the monitor, if you're looking at the monitor, if you don't see anything, that's probably because one of those cables is bad. On the other hand, if the monitor is at the head of the chain, you may not know for sure that whatever's going beyond the monitor still works. And there have been some very embarrassing situations where people have had entire programs that they weren't recording because they were looking at the program, but it wasn't actually being recorded. And so be very careful how you approach that. Of course, these days, with the digital signal, it's a whole lot easier. And it's also important to understand the video signal and to see how it works. And we're going to get into that in a future lecture.